This video is about programmer's model and processor modes in an ARM processor. All information is taken from ARM System Developer's Guide by Sloss, Symes, and Bright. In this video, we will cover user and system mode registers, program status registers, processor modes. This is a representation of the registers in an ARM processor. From top to bottom, R0 to R15, along with the CPSR and an empty registers. Together, the total count is 18 active registers. There are 37 total registers in ARM processor, but 20 registers are hidden from the program at all times. Note that all the registers are 32 bits in size. The 16 registers as shown on left, R0 to R15, are the data registers. R0 to R13 are orthogonal in a sense that any instruction can be put in any of those registers with the same effect. The three registers R13, R14 and R15 are for special function or a task. The two processor status registers are CPSR and SPSR, current program status register and saved program status register. Now we will see the three special function registers. R13 is the stack pointer and it stores the head of the stack in the processor mode. It can also be used as a general purpose register. It is useful when banked during a processor mode change. It is not advisable to bank this register when processor is running the operating system because operating system always assumes R13 to have a valid stack pointer. R14 is the link register and it is where the processor puts the return address when it calls the any subroutine. It can also be used as a general purpose register and it can be banked during a processor mode change. Banked means the register can be temporarily put to the same value use, but there is another banked register that get added so that further processor execution can happen on the new register. R15 is a program counter that contains the address of the next instruction that is to be fetched and executed by the processor. The program status register is used to monitor and control all internal operations. It is 32-bit in length and it is divided into four fields of 8 bits each. These four fields are flag, status, extension, and control, as shown in this figure. The flags, which are at the topmost uh, uh, 4 bits, which are uh, bit number 27 and onwards, which is bit number 27 is overflow and saturation, which is not shown in this diagram, but in the current ARM processor mode, bit 27 is signifying overflow and saturation. Bit 28 signifies signed overflow. 29-bit is unsigned carry. Bit 30 is the zero or equality. So when uh, any two uh, values are compared, the comparison result is uh, is is stored as 0 in bit 30 if they are equal. And bit 31 is for to signify the negativity of the value. If bit is set as 1, it is a negative value. Also, bit 24 is only used in Jazzle enabled processor and otherwise it is not used. The status and the extension fields are reserved for future use. For mode, the last 7 bits from 0 to 7, which are the which are the bits which are the control bits. Uh, they from those 8 control bits, the the 5 bits from 0 to 4, they signify the modes. There are 6 privileged modes and 1 user mode. In the privileged mode, uh, the the processor has read-write access to current program status uh, register, and in the user mode, it has only the read access. It cannot write or change the processor mode. The bit number 5 is signifying the thumb state, which is for the 16-bit thumb instructions, and bit number 6 and 7 are representing the interrupt mask bits. For processor modes, which are determined by the 5 bits from 0 to 4, we have seen that there are 6 privileged modes, and these can be enumerated using the combination of the 6, using the combination of the 5 bits as fast interrupt request, which is 1001, interrupt request, which is 10010. Then there is a supervisor mode. Usually, this is the mode when the embedded portable device is coming up, and this is the this is the mode where the OS operating system kernel operations execute, which is 10011. Then abort or a failed attempt to access memory is 10111. If there is anything which is undefined and not understood by the processor, the mode is 1011011, which is undefined. And finally, if all bits are 1, then it is a system mode, which is a special version of a user mode, which allows full read-write access to CPSR. This is used when the user mode has to operate or execute something and wants a special privileges temporarily, which can be given by the system mode. Now, for the single non-privileged or a user mode, the CPSR is only having the read access. The flag is 10000, and this is for all programs and application. Note that in the user mode, you do have read-write access to the condition flags.